Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So we'll be continuing from the session where we have stopped in the previous class. Okay, in the previous class we had seen what is the meaning of functions and also solved two examples based on the same. So we'll just have a quick recap on what we did in the previous class and we'll be continuing with today's session as well. So in the recap students, what we did was, we saw what was a function, correct? So how do you define a function? Where the first element does not repeat. So for example, 1, 3, okay, and 1, 5. Okay, so the first element is repeating here, right? Okay, if this is not happening, okay, then it is not called as a function. If this happens, it is not called as a function. It is called as what? A relation only. Okay, so what is a function then? How will function look like? Function will something look like this. 1, 3, 2, 5, 3, 7, and so on like that. Means each first elements will be having unique images of y. Okay, no two means these both x elements will not be same. Okay, so that is how we define a function. Understood? So this is what we saw in the previous class. So I hope you are very clear with that. So in today's session, what we'll be doing is the next topic of relations and functions. It is called as types of graphs or functions, some functions and their graphs. Okay. So we'll be discussing this today until the modulus function. In the next session, we'll be doing these both. Okay. In addition to this, we'll also be seeing the algebra of functions. So after doing these both things, okay, that will be the end of this topic. So in today's class students, what we'll be seeing is, okay, we'll be seeing these functions and their graphs. Okay, starting with the very first one, identity function. Okay, so what is an identity function? The definition is given like this. Let R be the set of real numbers. Define the real valued function f such that R to R by y is equal to f of x, which is equal to y. Okay. So as of now, if you're not understanding this, do not worry. I'll be also presenting a graph. Okay, just by looking at the graph, things will be very clear, students. All right. So let R be the set of real numbers. Define the real value of function f such that R to R by y is equal to f of x. And what is f of x equal to x? For each x belongs to R, such a function is called as identity function. Here the domain and range of f are R, means which is nothing but real numbers. So to understand this, what we'll be doing is we'll be going to the graph here. So this is nothing but identity function. So the function here, this is a function students. What is that? F of x is equal to how much? X. So that is what is given here. See, f of x is equal to x. Understood? Means y, what is f of x again? So here you can see again f of x is nothing but y. So which is nothing but equal to y. So y is equal to f of x. Whatever value of x you input, the same value the y will also take. If you want, you can just observe here. So see this point, the very first point. So what is the point here? It is 0, 0. X is how much, students? 0. Then y is also how much? 0. Identity function. Whatever x value takes, the same value will also be taking by y. Okay. See the next one here. 2, 2. So see this point is lying on the line, correct? This point, the blue point is lying on the line. What is the value of x? The value of x is 2. What is the value of y? The value of y is also 2. So what can we write here? Y is equal to x or f of x is equal to x. So what are you inputting in the place of x, students? In the place of x, you're inputting 2, right? So f of 2 is nothing but equal to 2 only. So that is nothing but equal to y. Understanding? So see the next point as well. 4, 4. X is 4, y is 4. X is 2, y is 2. Next. X is minus 2, y is also minus 2. X is minus 4, y is also minus 4. So this graph is representing what? So this is that function, identity function, and this is its graph. Function and its graph. So what is the function here, students? Function here is defined like this. This is how the function is defined. Y is equal to f of x is equal to x, which is nothing but called as what? Identity function. And this is its graph. So here the domain and range of the function are what? The set of real numbers. Understood. So this is the very first type of function called as identity function. Moving on to the next type of function. It's called as constant function. So again, we'll be seeing the definition and also the graph as well. Okay, what is constant function? So function f such that r to r by y is equal to f of x is equal to c. Previously what, students? How do we define identity function? Y is equal to f of x is equal to x. This is what? Identity function. Correct. Now what is constant function? Y is equal to f of x is equal to c or any other alphabet k, something like that. But why? What is this c? This c is nothing but a constant. It is a constant. Okay. So x belongs to the set of real numbers where c is a constant. Correct. Where c is a constant and each x belongs to r. Here the domain of f is r and its range is c. Okay, the range is c. Means the, what is range again? Domain and range. So x comma y, right? This is how we represent what? Relations and functions. Ordered pairs, set of ordered pairs. The first element always represents what? Domain. The second element always represents what? Range. So what is the domain here? Here the domain of f is r, that is set of real numbers, and range is c. So this is getting fixed. Okay. So it will be c, whatever c we have. So we'll see its graph now. Understood? So see this point. Okay, remember this. Y is equal to f of x is equal to x, identity function. Y is equal to f of x is equal to c, constant function. Domain, set of real numbers. Here, range, constant c. Okay. So the graph of this function is represented like this. So see this. So here, the function of this f of x is equal to 3. So that is nothing but y is equal to 3. Why y is equal to 3? Because y is equal to f of x. Now if you want to see the points here, students, see the very first point. So this is 1, correct? 0, this is 1, 2, this is 3, then we have 4 there. Here also same thing, 0, minus 1, minus 2, minus 3 and minus 4, correct? So now 1, that is nothing but what? Real number. What is its range? So this is 2, correct? So 0, this is 1, 2, so this will be 3, correct? 1 comma 3. This line is going infinitely, students, like this as well as like that. Okay, it's going infinitely. So set of real numbers. So next, see the next one here, 1 comma 3. The next one would be 3 comma 3. So see the range here. It is c. See the range here. C. See the next one. Range is c. Range is c. What is c equal to? C equal to 3 we have taken. What is the function of the graph? The function of the graph f of x is equal to 3. That is nothing but y equals to 3. Why is that? Because y is equal to f of x. That is okay. Moving on to the next one. So here this is 3, this is 3. So what is the range, students? What can you see the range as? The range is 3. Whereas what is the domain? Domain is nothing but the set of real numbers. See, minus 3, minus 1, 1 and 3. Understanding? So this is called as what? This is called as a constant function. Y is equal to f of x is equal to c. X belongs to r. Domain of f is r and its range is c. Alright, moving on to the next function. So the next function is polynomial function. A function, so again we'll read the definition, have a look at the graph, understand it very nicely. Okay, a function f such that r to r is said to be a polynomial function, comma, if for each x in R set of real numbers, y is equal to f of x is equal to, so see this, y is equal to f of x is equal to x. Which function? Identity function. Okay, y is equal to f of x is equal to c. Which function? Constant function. Now polynomial function, now students, y is equal to f of x is equal to a naught plus a1x and a2x square and so on until an xn. So this is like how the identity function is defined like this. Constant function is defined like this in the very similar manner. The polynomial function is defined like this, where n is a non-negative integer and a1, a2, a3 all until an is belonging to the set of real numbers. Alright. So here I have taken one example. On the left hand side you can see the graph. So what is the graph I have taken here is y is equal to x cube polynomial. Okay. What is x square plus 0x square? And what is x plus 0x? And what is the constant? 0 again. Polynomial, right? Only x cube, what is the constant of x cube? Numerical coefficient, I'm sorry. It is 1. Understood? So we'll just erase that. This part will erase. Okay. So this is the polynomial function. Here we'll write f of x equals x cube, which is nothing but y is equal to x cube. Understood? So the here n is equal to plus n, correct? N is equal to the positive integer. The same thing is written here, where n is a non-negative integer. So n is equal to 3 there, correct? A1, A2, A3 are what? Belonging to the set of real numbers which are constants. So what is the constant here? The constant here is 1, and here we have a positive integer. So on this graph, if you see the points will be something like this: minus 1 comma 1, 1 comma 8. Another point if you have to plot, then for 2 it will be equal to 8. So here we can write 2 comma 8. So the graph is not so big. And here also the same thing, it will be minus 2 comma y is equal to x cube, right? So see here, y is equal to x cube. Now if you are putting x is equal to minus 2, what will y be equal to? Minus 8. Understanding? So this is nothing but what? A polynomial function, where y is equal to f of x, which is equal to a0 plus a1x plus a2x square until an xn, where a0, a1, a2 and an are called as what? Or they are belonging to the set of real numbers, and this n is nothing but a non-negative integer. So this is called as what, students? A polynomial function. Okay, moving on to the next one, rational function. So polynomial function you saw, right? Rational function is, so rational functions are the functions of the type f of x by g of x. F of x by g of x. What is this equal to? Y. What is f of x? A polynomial. Polynomial we just now saw, right? What is polynomial function? Same thing, but in terms of division. And g of x is also nothing but polynomial function with a condition: g of x is not equal to 0. So this is what you have to remember for rational function. So read the definition: are functions of the type f of x by g of x, where f of x and g of x are polynomial functions. So this is what we saw previously, polynomial functions of x defined in the domain where g of x is not equal to 0. So for example, the graph of this rational function is something like this. So see the graph there, it is not continuous, okay, because here the function y is equal to, what I have taken is x plus 1 by x minus 1. So see the points on the same, minus 1 comma 0 and 0 comma minus 1. So this is nothing but what, students? So just what you have to remember is, if y is equal to f of x by g of x, where f of x and g of x both are polynomials, then that type of function is called as what? A rational function. Okay. Moving on to the next one. The important one, students, modulus of a function. So very simple it is. The definition might seem a little bit confusing, okay? But with the help of the graph, we can easily understand the definition and we can proceed further. Alright, now see the definition. The function f such that r to r defined by f of x is equal to mod of x. This is important. So just once again, one quick revision including modulus of function. So y is equal to f of x is equal to x. Y is equal to f of x is equal to c. Y is equal to f of x is equal to a0 plus a1x plus a2x square. This will continue until an x to the power of n. Y is equal to f of x is equal to what we saw next before this, rational function. So y is equal to f of x by g of x. In the bracket you can write g of x is not equal to 0 and f of x and g of x are polynomial function. And the very last one, this one, y is equal to f of x, which is equal to mod x. So students, this is what you have to remember. Okay, these are not all the functions. There are two more functions, as I said in the earlier. Okay, very beginning of the class. So those will be doing it in the next class. Now, which type of function is this? Identity function. Which type of function is this? Constant function. Which type of function is this? Polynomial function. Which type of function is this? Rational function. And which type of function is this? This is a modulus function. Modulus of a function. So to remember, you have to remember all these things, students. Now we'll see what is modulus of a function. Okay. So modulus of a function, the function f such that r to r defined by f of x is equal to mod x for each x belongs to r. Students, important. Okay. For each x belongs to r is called as a modulus function. This is not the end of the definition. For each non-negative value of x, f of x is equal to x. Non-negative value of x. So what is non-negative value of x? So let us take x is equal to 1. Then what is f of x, students? Read this again. For each non-negative value of x, f of x is equal to x. If x is equal to 1, what is f of x? F of x is also equal to 1. If x is equal to 19, what is f of x? F of x is also equal to 19. Okay. Now see the next statement here. We'll change the color. But for negative values of x, let us take x is equal to minus 1. But for negative values of x, the value of f of x is negative of the value of x. Understand this point. The value of f of x is negative of the value of x, which means f of x is negative of the value of x, which is nothing but equal to plus 1. I hope it's clear. Once again, I'll repeat. For each non-negative value of x, x is equal to 1, x is equal to 19. F of x is equal to x. F of x is equal to 1, f of x is equal to 19. Okay. Next line. But for negative values of x, x is equal to minus 1. The value of f of x is negative of the value of x. What is x? Minus 1. Negative of the value of x, which is equal to plus 1. Understood, students? Okay. Any doubts here? Okay, if you did not understand any particular line, okay, you can just let us know by commenting in the comment section. So we'll see the graph of this modulus of function. Okay, on the left hand side. So see, this is how the modulus of function looks like. Okay, we'll go to the next slide. There are some marks here. So see this. Coordinate, students, 0, 0. The very first point what we have taken, what is x? X is positive, correct? X is equal to plus 2. What is f of x? F of x is also equal to plus 2. What is f of x, students, actually? F of x is nothing but y. X is equal to 2, y also equals to 2. See the next point. X is equal to 4. F of x is also equal to 4. X is equal to 2. F of x or y is equal to 2. But you see on this side, students, if f of x is negative of 2, if x is negative of 2, so what is happening here? X is equal to negative of 2. What is f of x? F of x is negative of minus 2, which is equal to plus 2. We are getting plus 2. Same thing, x is equal to minus 4 we have, correct? X is equal to minus 4. What is f of x? F of x is minus of minus 4, which is equal to plus 4. See here, plus 4. The same thing is defined in the definition. See, but for negative values of x, what is x? X equals minus 4. The value of f of x is, f of x equals the negative of the value of x, minus 4, which is equal to what, students? Plus 4. And this is how the modulus of the function is defined as. Okay. Another term which you can remember here is, so I'll just write down here. So if f of x is equal to, okay, f of x is equal to negative of x if x is lesser than 0. F of x is positive of x if x is greater than or equal to 0. So this is also one of the terms. Okay. Apart from this, what you have to remember the most is the functions, how are they defined? So we'll just have a quick revision on that. 5 functions we saw today. Y equals f of x, 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 and y equals f of x is equal to x, is equal to c, is equal to a naught plus a1x plus a2x square until an x to the power of n, f of x by g of x, where g of x is not equal to 0, and f of x is equal to minus x for x lesser than 0 and plus x for x greater than or equal to 0. So students, this is the summary of today's session. Okay, identity function, constant function, polynomial function, rational function, and modulus of a function. I hope it is clear. So this is what you have to remember, students. I have also shown you some graphs, so also remember them, and that's it. So this is very important. So you can just make a note of this. Apart from that, so 2 more functions are remaining, which are nothing but signum function and greatest integer function. Along with that, we'll also be doing the algebra of the functions in our next session, and that will be the end of the second chapter in class 11 mathematics. So I'll be seeing you in the next session very soon, students. Until then, like, subscribe and share to Vista's Learning. Thank you.